Hello everyone, welcome to our channel The Digitex. Today let's understand quantum computing and why it will change everything. What if there was a computer so powerful it could solve problems in minutes that today's fastest supercomputers would take thousands of years to solve? That computer already exists and it's called quantum computing. In this video I will explain what quantum computing really is, how it works and why it's going to change everything. Quantum computing. This is a name we have been hearing very strongly in recent times. So, what exactly is it? It is an advanced technology that is bringing revolutionary changes to the world of technology. It is a new age innovation that has the power to solve extremely difficult problems at unimaginable speed, no matter how huge the data is. This technology has the capability to analyze it in blink of an eye. Quantum computing is already creating wonders, and if it becomes accessible to everyone, the course of the entire world will change. Let's understand quantum computing with some real time examples. To understand quantum computing, let's start with simple card game, the queen and the cards analogy. Imagine you have 1 crore deck of playing cards. That's 52 crore individual cards. Your goal is to find the queen. A classical computer works like a human guessing cards. It checks the first card, not the queen, then the second card, then the third, until it finally finds the queen. That's how classical computers work, one step at a time. Now, here's the quantum twist. A quantum computer can find the queen in a single attempt, and it doesn't matter if there are 4 cards, 1 crore cards, or even 100 crore cards. That's the power of quantum computing. A quantum computer does not check cards one by one like classical computers. Instead, all 52 crore possibilities exist at once. This is called superposition. Let's take another real-time example of quantum computing in drug discovery. A pharmaceutical company wants to create a new drug to treat a disease. Classical computers simulate them one at a time. Testing all possible molecular combinations takes years, sometimes 10 to 15 years, and costs billions. Progress is slow because of molecular behavior. Quantum computers can simulate multiple molecules simultaneously. This is called superposition. Understand interactions at the quantum level. Use interference to eliminate non-effective molecules instantly. Classical computers testing for 10 million molecules takes years of lab experiments. But quantum computing testing for 10 million molecules done in hours or days on a quantum simulator. To understand quantum computing, let's take another real-time scenario of Google Maps. Imagine Google Maps recalculating routes for millions of users at the same time, considering traffic, accidents, weather, road closures. Classical computers check routes one by one. Quantum computers evaluate millions of routes simultaneously, finding the best possible traffic flow for entire cities in seconds. Why it's interesting? Google Maps today takes seconds to update routes for few cities in the world. Quantum computers could do it in milliseconds for entire cities in the world. That's the power of quantum computing. Let's take another real-time scenario of quantum computing explained with a maze game. Imagine the scenario. You are in a huge maze with millions of possible paths. Your goal is to find the exit as fast as possible. Classical computers are like a player who checks one path at a time, works step by step. Time taken to complete is minutes, hours, or even days for a huge maze. A quantum computer is like a magical player who can explore all paths simultaneously. This is called superposition. Time taken will be seconds or milliseconds for the same huge maze game with quantum computing. How quantum computing works? Quantum computers operate on the principles of quantum mechanics and are significantly more powerful than the supercomputers we use today. Quantum computer is approximately 15 million times faster than a current supercomputer. To understand quantum computers, let's try to understand how transistors works. In the early days of computers, machines were huge, entire rooms filled with hardware. Over the time, computers became smaller and more powerful because of one key invention, the transistor. A transistor works like a small electrical switch. When it's on, electricity flows. When it's off, electricity stops. All modern computers are built from billions of these small switches. Moore's law explained simply. For decades, engineers followed a trend called Moore's law. It states that every 18 months, the number of transistors on a chip doubles. More transistors in the same space means faster, more powerful computers. This is why your phone today is more powerful than computers from 20 years ago. The physical limits. But now we have hit a serious problem. Modern transistors are incredibly small, as small as 2 nanometers. At this scale, we are working almost at the atomic level. Transistors simply can't be made much smaller without breaking the laws of physics. Why this leads to quantum computing? As transistor scaling slows down, classical computers can no longer improve at the same speed. So scientists started looking for a completely new approach using the new rules of quantum physics instead of quantum electronics. We shrink transistors until we reach atoms. Now we need an entirely new way to compute, and that new approach is quantum computing. For decades, our traditional computers have spoken a simple language, bits. A bit is either a 0 or a 1. It's like a light switch that's either on or off. Our smartphones, our internet, our AI, it's all runs on billions of these simple switches. Quantum computers use qubits. Here's the big difference. A qubit can be 0 and 1 at the same time. This isn't a trick. It's based on quantum physics, the rules that govern particles at the smallest scale. Because of this, quantum computers can explore many solutions at once, not one at a time. This means quantum computers can explore countless possibilities simultaneously. This is where quantum computing steps in, and it's where things get faster. In the best possible way, instead of bits, quantum computers use qubits. Think of a qubit not as a light switch, but as a spinning coin. It can be heads 0, it can be tails 1, but while it's spinning in the air, it can be both heads and tails at the same time. This magical state is called superposition. Superposition allows a qubit to hold multiple possibilities simultaneously. This means a quantum computer can explore many solutions to a problem at the same time, not one after another. Imagine countless roads taken at once. Entanglement. This is even stranger. When two qubits are entangled, they become deeply linked. If you measure the state of one, you instantly know the state of the other, no matter how far apart they are. It's like having two magic coins that always land opposite each other. Even if you toss them on different planets, this allows quantum computers to perform calculations across. What quantum computing can do: drug discovery and material science. Instead of years of trial and error in labs, quantum computers could simulate new molecules and materials perfectly, leading to revolutionary drugs, super efficient batteries, or carbon computing materials. Cybersecurity. Today's encryption depends on problems that are hard for classical computers to solve. Quantum computers could potentially crack almost all our current encryption, forcing a complete redesign of global security. But also, they could create unbreakable quantum encryption. Artificial intelligence. Imagine an AI that could learn and process and thinks and keeps getting smarter. Financial modeling. Optimize complex portfolios, detect fraud, and predict market fluctuations with unprecedented accuracy. Logistics and optimization. Solve incredibly complex delivery routes, optimize traffic flow, or manage global supply chains with perfect efficiency. Quantum versus classical computers. Classical computers follow step by step logic, are great for emails, videos, and apps. Quantum computers work in parallel, excel at complex calculations, solve problems classical computers can't. Quantum computers won't replace your laptop, they will work alongside classical systems. Who is leading the quantum race? Quantum computing changes how we solve problems, not just how fast we compute. It allows humanity to tackle challenges that were previously impossible. That's why governments and tech giants like Google, IBM, Microsoft, and Amazon are racing to build them. This is often called the new space race of technology. Why you should care? Quantum computing isn't just for scientists. It will create new careers, transform industries, redefine what computers can do. Understanding quantum computing today means being ready for tomorrow. If this video helped you understand quantum computing, hit like and subscribe. Thank you for watching the Digitex. See you in the next video.